Hey there. This is part 2 of the pH Mastery series, and here we'll cover how to answer questions involving strong acids and bases.
With strong acids, the three most common ones I've seen are hydrochloric acid, nitric acid, and sulfuric acid. Basically, when something begins with an H, you know you're dealing with an acid. And you might also see these ones as well in the top left corner. When acids get deprotonated, or you might see the word disassociated, it just means that it loses a hydrogen. And with strong acids placed in water, this happens 100% of the time. So if we only just look at the H+, finding pH will be relatively easy since we know that negative log of it will get us the pH. So when we say strong acids disassociate or deprotonates 100% of the time, let's take an example. Let's say we had 3 molars of HNO3. That means H plus is 3 molars, so to find pH, just take the negative log of it, and that gets us our answer. So find pH of a 0.02 molar solution of HCl. We know HCl is one of the strong acids, and that means it will disassociate 100% of the time. So if there's 0.02 molars of HCl, then that means that that's how much H plus we have. So from there, set up the pH equation and plug in the H plus concentration. And that gets us our answer. For strong bases, there are 3 main ones: lithium hydroxide, sodium hydroxide, and potassium hydroxide. Basically, whenever you see an OH, you know you're dealing with a base. And you might also see these ones in the top left corner as well. Like how strong acids disassociate 100% of the time, so do our bases. But instead of H+, you have OH-. So let's just look at that on its own. So we know from last video that OH- can easily get us the POH by taking the negative log of it. So if we had 0.1 molar NaOH, that's how much OH- we have. So we take the negative log of it, and that gets us our POH. So find the pH of a 0.02 molar solution of KOH. So we recognize KOH as one of the strong bases. And we know that with strong bases, if there's 0.02 molars of it, then that's how much OH- we have. Next, we'll plug this into the POH equation, which gets us our POH. But the question asks us for pH. So we'll use this equation that we learned from last video, that pH plus POH equals to 14. And after plugging our POH, we get us our answer. So an important thing to restate is that acids start with a hydrogen and bases end with an OH. The exception of this is COOH, which even though you see an OH, it's an acid called acetic acid.
For weak acids, don't worry about memorizing, since in problems you'll see this thing called a Ka value. Just know that if you see a Ka value, you know you're dealing with a weak acid or a base, and finding pH or POH won't be that easy.
In the next video, we'll talk about problems dealing with mixtures of acid and base and how to do some ice tables. I'll see you there.